Hello everyone, thank you for watching my video. I'm Mr. Matt. This is Dr. Tot. You want a cookie, Dr. Tot? Start class. And welcome to SAT, ACT Prep. This is Quick Drill Set B. We're going to go through two clusters of three alternate examples. These are SAT, ACT Advanced math problems pertaining to the rules of exponents in the arithmetic math section. So let's go ahead and get started. The document, let me share my screen with you. The document is going to be listed, a link will be listed in the description shortly after the video is posted. So the resource number to this document is 1000-8, so you can just make sure that you're looking at the right problem set. We're going to go through these problems without delay, so I'm going to read the problem. You should pause the video, attempt the problem, and then watch a solution. So question number 1, if 4 raised to the x minus 4 power is equal to 8 raised to the negative 1 times the quantity x plus 6 power, then what is the value of x? So pause the video and attempt that problem. So first of all, we can recognize that we have two numbers on either side of an equal sign that are being raised to exponents. So in some way we would want to use the rules of exponents. Remember, the governing rule, however, is that we need common bases. Right now the bases are not common. We have a base of 4 on the left side and we have a base of 8 on the right. So we need to try and rewrite these bases in terms of the same number. So ask yourself, is there a number that we can exponentiate or raise to different powers that we can get 4 and 8? And the answer is yes, because we can recognize that 2 to the first power is 2. 2 squared is 4, and 2 cubed is 8, because 2 times 2 times 2 is 8. So I'm going to replace 4 and 8 in terms of an exponentiation of 2. So I just need to make sure that I use parentheses really carefully here. So instead of 4, I'm going to write 2 squared. That's still raised to the x minus 4 power. Instead of 8, I'm going to write 2 cubed. And again, that's still raised to the negative 1 times x plus 6 power. I'm going to simplify on the right-hand side by distributing that negative sign within the parentheses. This negative needs to be thought of as a negative 1, and it needs to go to both values, both the x and the positive 6 inside the parentheses. That's a really common error there. So this is going to, whoops, I'm sorry. So on the right, I'm just going to still keep, on the left, I'm going to keep that the same for now. But on the right, we're going to have 2 cubed times the quantity negative x minus 6, just distributing that negative sign within the parentheses. Now I have powers of powers on both sides. I have exponents of 2 and the quantity x minus 4 on the left. I have exponents of 3 and the quantity negative x minus 6 on the right. So I can multiply. Again, you need to make sure that you distribute within these parentheses. So the 2 and the 3 need to go to both values inside the parentheses. So then we're going to have 2 raised to the 2x minus 8 power is equal to 2 to the negative 3x minus 18 power. Now we have bases, two bases on opposite sides of an equal sign, or in other words, we have numbers raised to exponents on opposite sides of an equal sign. So we can drop the bases and equate the exponents. So 2x minus 8 has to be equal to negative 3x minus 18. And I'm going to bring this over here just for space. So I'm going to add 18 to both sides. That'll simplify on the right. So then I'm going to have 2x plus 10 is equal to negative 3x. I'm going to subtract away 2x on both sides. So then 10 is going to be equal to negative 5x. Dividing by negative 5, x is equal to negative 2. And that's answer selection B. Number 2 asks, if 4 raised to the negative 5x plus 15 power is equal to 32 raised to the negative 1 times the quantity x plus 3 power, then what is the value of x? So pause the video and try that problem. So again, we have the problem that we don't have common bases on opposite sides, so we can't use any of the rules of exponents as they're listed. 4 is a little bit tricky because 4 is itself a perfect square of 2. So when you're investigating exponentiations of 4, you always need to also consider, that's redundant, you should also consider exponentiations of 2. Notice that you can't exponentiate 4 and get 32. The exponentiations of 4 jumps over 32. 4 to the first power, let me write this out. 4 to the first power is 4. 4 squared is 16. 4 cubed is 64. It jumps over 32. However, exponentiations of 2 do include 32. 2 to the first power is 2. 2 squared is 4. 2 cubed is 8. 2 to the fourth is 16. 2 to the fifth is 32. So we want to use exponentiations of 2, not 4, because 4 is not going to work for 32. So instead of 4, I'm going to write 2 squared. And that's still raised to the negative 5x plus 15 power. Instead of 32, I'm going to write 2 to the fifth. And that's still raised to the negative 1 times the quantity x plus 3 power. I'm going to simplify on the right just by distributing that negative sign within the parentheses. Notice it needs to go to both the x and the 3. So the left-hand side is going to remain unchanged for this step. The right-hand side is going to be 2 to the fifth raised to the negative x minus 3 power. Now we have powers of powers, so we can multiply. Making sure that we distribute through, the 2 needs to go to the negative 5x and the 15. The 5 needs to go to the negative x and the negative 3. So we're going to have 2 to the negative 10x plus 30 is equal to 2 to the negative 5x minus 15. Now we have common bases on opposite sides of an equal sign, so we can drop the bases and equate the exponents. So negative 10x plus 30 has to be equal to negative 5x minus 15. Adding 15 to both sides, so the 15 cancels on the right, we're going to get negative 10x plus 45 is equal to negative 5x. And let me just take this over here. Oops. Adding 10x to both sides to cancel on the left is going to leave me with 15x is equal to positive 5x. Negative 5x plus a positive 10x is going to give me a positive 5x. Dividing by 5 on both sides is going to leave me with x is equal to 9. And that's answer selection C. Question number 23. Question number 3. If 27 raised to the 8x minus 10 power is equal to 81 raised to the 3x plus 4.5 power, then what is the value of x? So take a few moments and solve that. So here, same problem. We have different bases, so we can't use any of the rules of exponents. These are not even numbers, so they're probably not exponentiations of 2 or 4. So let's look at 3. Notice that 3 to the first power is 3. 3 squared is 9. 3 cubed is 27. 3 to the fourth power, or the quartic power, is 81. So instead of 27, I'm going to write 3 cubed. That's still raised to the 8x minus 10 power. Instead of 81, I'm going to write 3 to the 4th power. And that's still raised to the 3x plus 4.5 power. Now I have powers of powers, so I can distribute the 3 to the 8x and the negative 10, and the 4 to the 3x and the 4.5. 3 times 8x is 24x, so this is going to turn into 3 to the 24x minus 30th power. Oops, got my x. On the right-hand side, 4 times 3x is 12x, so this is going to be 3 to the 12x power. 4 times 4.5, 4.5 times 2 is 9, 9 times 2 is 18, so 4.5 times 4 is the same thing as 4.5 times 2, and the result times 2. So that's going to be 18. Now we have common bases on opposite sides of an equal sign, so we can drop the bases and equate the exponents. So 24x minus 30 is equal to 12x plus 18. If I add 30 on both sides, then I'll have 24x is equal to 12x plus 48. Subtracting 12x on both sides to eliminate the 12x on the right, I'm going to now have 12x is equal to 48. Dividing by 12, x is equal to 48 divided by 12, which is 4. And that's answer selection B. New question type. Which of the following expressions is equivalent to the quantity 4x squared, quantity raised to the negative 2/3 power? A is 1 divided by the 3rd root of 2x. B is 1 divided by the 3rd root of 2x squared. C is 1 divided by x to the 3rd power times, C is 1 divided by x to the 3rd power times the square root of 2x. And D is 1 divided by 2x to the 3rd power times the square root of 2x. I'll give you a few minutes. So looking here, remember that we can translate fractional exponents to radicals using a certain formula, and we can also get rid of negative exponents with a certain formula. So anything raised to a negative exponent is just equal to 1 over that number raised to the positive version of that exponent. So I can rewrite 4x quantity squared to the negative 2/3 power. I can rewrite that as 1 over 4x squared to the positive 2/3 power. Now also, remember that any number, actually let me use a different letter for the base, any number raised to a fractional exponent, so like a raised to the m over n power, that's equal to the nth root of a to the m power. So the denominator of the exponent becomes the index value of the radical. The numerator of the exponent remains the exponent of the radicand. The radicand is the number underneath of the radical sign. So we can use these two formulas to simplify here. So now I'm going to simplify the denominator using that second formula. I still have 1 over, but raised to the 2/3 power, that's the same thing as the 3rd root of 4x squared quantity squared. Now you need to make sure that this squared goes to everything inside of the parentheses, the 4 and the x squared. So now this is going to turn into 1 over the 3rd root of 16 times x to the 4th power. 4 squared is 16. 2 squared raised to the 2nd power is 2 to the, x squared raised to the 2nd power is equal to x to the 2 times 2 power, which is x to the 4th power. Now to simplify radicals, if this index value is 3, that means for every 3 factors underneath the radical sign, we can pull 1 factor out. So if we look at the factorizations of 16, 16 breaks down into 8 times 2, 8 breaks down into 4 times 2. 4 breaks into 2 times 2. So 16 is the same thing as 2 to the 4th, or in other words, 2 4 times. So if you were to write these out, if it helps, you can always write them out. So this is the same thing as the third root of 2 times 2 times 2 times 2 times x times x times x times x. Because there's 4 2's, 16 is the same thing as 2 to the 4th power, and x to the 4th is the same thing as x times x times x times x. So if this is the third root, for every 3 underneath, we can pull 1 outside. So this is going to simplify into 1 over 2 times x, and then we still have the third root of 2x underneath the radical because we weren't able to pull the last 2 and the last x out because it's only the third root. So now our answer here is going to be 1 over 2x to the third root of 2x. And that's answer selection D. Notice in this problem, they did not rationalize the denominator, so they left a radical in the denominator. Usually they won't do that, but this was, in this case, they left it unrationalized, so just note that sometimes if your answer selections didn't match that last form that we solved for there, you might have to multiply by the third root of 2x over the third root of 2x in order to get the radical out of the denominator and have your answer in simplified final form. In the next two problems, we're going to look at examples that require that. So number 5, which of the following expressions is equivalent to the quantity 8x squared, quantity raised to the negative 3/2 power? A is the square root of 2 divided by 32 times x to the third power. B is the square root of 2 divided by 8x cubed. C is the square root of 2 divided by 16x cubed. And D is the square root of 2 divided by 4x cubed. Take a few moments, pause the video, and solve this problem. So same type of thing here as in number 4. First, we can translate this into a positive exponent by just writing it under 1. So this is the same thing as 1 divided by 8x squared, quantity raised to the positive 3/2 power. Now we can translate that fractional exponent into the square root of the quantity 8x squared, quantity raised to the third power. 8 to the third power is 512. So this is going to turn into 1 over the square root of 512 x to the 6th power, because we have a power of a power. So we'd multiply the 2 and the 3 together to get the exponent of x. We're raising 8 to the third power to get 512. If we look at the exponentiations, or the factorization, I should say, of 512, well, we made 512 from 8 to the third power, so 2 factors has to be 8 and 8 squared, or 8 and 64. 64 breaks down into 8 and 8, and each of these break down into 2 and 4, 2 and 2. So I'm just breaking this number down into its prime factors. This is a rather large one, and you can see that it has 1, 2, 3, 4, 5, 6, 7, 8, 9. 512 is the same thing as 2 to the 9th power. So again, if I wrote this out, and once you get familiar with this process, you don't have to write this out at each time like this, but just to show you, if I have 9 2's and I have 6 x's, and if it's the square root, that means for every 2 underneath, every pair, I can bring 1 outside. So then this is going to simplify into 1 over, I can bring 1, 2, 3, 4 2's, and I can bring 1, 2, 3 x's, and I'm still left with the square root of 2 underneath the radical. So this will simplify into 1 over 2 times 2 times 2 times 2 is 16. X times x times x is x to the third. And then I still have root 2. Notice that that doesn't match any of our answer selections. So I need to rationalize the denominator. I need to get rid of the radical sign. It's technically not appropriate to leave a radical sign in the denominator. So I'm going to multiply by some version of 1 that's going to eliminate that radical. Namely, I'm going to multiply by itself in the numerator and denominator. So your final answer here is going to be root 2 over, when I multiply by root 2 in the denominator, that's going to be equivalent to 16x to the third times root 2 squared, because it's literally root 2 times root 2. So that's where this simplifies that radical out of the denominator, because this turns into 16x cubed times 2. And so our final answer is going to be root 2 over 32x cubed. And that's answer selection A. And last problem in this drill set B, which of the following expressions is equivalent to the quantity 9x cubed, quantity raised to the negative 3/2 power? So pause the video and attempt that problem, and then watch the result, the solution. So first, let's translate that negative exponent away. So we have 9x cubed 1 over 9x cubed raised to the positive 3/2 power. And then let's translate that fractional exponent into the square root of the quantity 9x cubed, quantity cubed. Cubing here, we're going to have 1 over the square root. I'm just applying this cube to both the 9 and to the x to the third. Now 9 to the third power I believe is 729, but let me just check that. Yep, 9 times 9 is 81, 81 times 9 is 729. Oops. So we're going to have 729 x to the 9th, because 3 times 3, and we have that power over powers multiplication. So 729, we got that from cubing 9, so I know 9 and 81 are factors. 9 breaks down into 3 times 3. 81 breaks down into 9 times 9, both of which break down into 3 times 3. So you can see that 729 is the same thing as 3 to the 6th power. So this is 1 over, this is going to be a long one, the square root. 729 I can represent as 3 times itself 6 times. X to the 9th power I can represent as x times itself 9 times. It's the square root, so for every pair I can bring 1 outside. So then this is going to turn into 1 over, I can bring 1, 2, 3 3's out, so I'm going to have 3 times 3 times 3. And I can bring 4 x's out, so I'm going to have x times x times x times x. And I'm left with 1 x underneath the radical, so I'm going to have the square root of x remaining. So that's going to simplify into 3 times 3 times 3 is 27. X times x times x times x is x to the 4th times the square root of x. That's not an answer selection, so we have to rationalize the denominator here. I'm going to do that by multiplying by root x over root x, multiplying by the radical itself. So that's going to leave me with root x over 27x to the fourth times root x squared. Root x times root x is root x squared. That cancels because the square root and squaring are opposite operations. So that leaves me with the square root of x over 27x to the fourth. Because the square root and the square cancel with each other, that turns into just x. So your final answer here is going to be the square root of x over 27x to the fifth. And that's answer selection D. If you have any questions, then please let me know in the, oops, my camera's going all crazy. Sorry about that. Let me get that right. There we go. Sorry about that. So thank you very much for watching. If you have any questions, then please let me know in the comment section. Also, I'm available on my social media accounts. I'll be releasing a whole bunch of videos this week, and I hope you have a wonderful day, and I'll talk to you all soon. Dr. Todd, do you want to say goodbye to everybody? Come on. You want to get a cookie? You guys say goodbye. Come on. Can you say bye? Can you say bye? No, come on. Say bye. 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 Very good. There we go. I was a little bit lazy at first. Thank you guys very much for watching. Have a great day. I'll talk to you all soon.